So what I wanted to do first of all was a little bit of a recap on Creo, like where we've come from, how we got to Creo 9, and then we'll get into Creo 9. So Creo's been around for a while in terms of the release history. We had Creo launched way back in June of 2011, Creo 1. So when we moved up from the old Pro Wildfire, we had 2 fairly soon after that, 3, 4 back in 2016, 5 in 2018. Then we moved to an annual release. Okay, so we had 6 in 2019, Creo 7 in 2020, Creo 8 in April of 2021, and then we had Creo 9 was launched in April of this year. Okay, and we're expecting to see Creo 10 in April of next year as well. All right, and I'll talk more to that a little bit later on. So one of the things I just wanted to mention. This came up with a few customers when we were preparing for the launch events, and it was about the release cycle, release cadence for Creo. So we did talk about this way back at some of the earlier events. We did back in Creo 6 days and things like that, where PTC sort of announced this. So, PTC used to have this concept of an enterprise and standard release cycle. Okay, so basically Creo 4 was an enterprise release, Creo 5 and 6 were standard releases, and Creo 7 was an enterprise release. So basically every third release was going to be an enterprise release. Okay, so the idea of those enterprise releases was that they had a 4-year life cycle. So that meant 4 years of maintenance builds, the old M10, M20, now it's dot versions. Okay, but 4 years of those maintenance releases. Whereas the standard releases, which back then was 5 and 6, were just basically a 1-year release cycle. Okay, so they're pretty short. So the idea of those enterprise releases was essentially that PTC's got some very, very big customers that have a lot of users. Paul and I met a CAD admin from John Deere a few years ago at the PTC conference in the US, and we're talking to him. He looks after 5,500 users around the world, Creo users, right? So companies like that, they don't jump every year. Okay, so they want a big release that'll sit there. They know they can sit on it for 3 years. There'll be maintenance builds if there are any bugs that they find or whatever else, and they can sit on those. Okay, so that was what PTC was doing for through the life of sort of Creo 4 to 7. Now with Creo 8, they changed that approach. So now with Creo 8 onwards, they all have a 4-year release cycle. Okay, so that's 4 years of release support. Okay, so we're seeing that now. So like Creo 8, which came out back in 2021, there'll be maintenance builds of that out until 2025. Okay, so I guess the thing there is that I know a lot of people used to wait. Then we had some customers who sort of waited they jumped to Creo 7, and then the plan was to sit on Creo 7 until Creo 10 came out, which was going to be the next enterprise release, because that was going to have 4 years. I guess what I just want to point out is that you don't have to wait until that for a 4-year release version, because Creo 8, Creo 9 are already have 4-year plans. Okay, so I just want to mention that. So let's talk about, I guess, some of those where we got to. So Creo 7, Creo 8, that's some of those recent releases and what's been happening with those. So with every release of Creo, there's always these sort of high-level themes. One of the core ones being just the general productivity enhancements, as well as some other topics you can see here. So I guess with Creo 7, when that got launched, there was a few things there around generative, answer-powered simulation, multi-body, additive and subtractive. So to talk about them in terms of the productivity enhancements, all the usual things, right? There's hundreds of these in every release of Creo. I'm going to get deep into what's there in Creo 9 later on today. But general things around usability, sketching, MBD. There are some very nice new tools in Draft. I had some customers, I remember, who basically, once they saw that, basically went back to the office and installed Creo 7 that afternoon because they wanted to start using some of that stuff. Okay, so tons of general enhancements to make life easier and more efficient. But some other sort of more other bits of technology, okay, around the Creo releases. So generative design. So generative design, for those who aren't familiar with it, generative design is basically the idea of letting the computer come up with a design. So the idea is that you give it some conditions, so some geometry. So you might say these are bits of geometry that must be fixed. You can see down here, my little screenshot here. So these blue bits, I must have them because I've got an interface there. This box around here is the area where you can do whatever you like. I'll give you some materials, I might give you some manufacturing processes, some loads and constraints and other things, and then go off and solve that for me. Okay, and so you feed to the computer, it grinds away and comes up with some weird and wonderful shape that you'd never come up with yourself in a million years, right? To minimize weight, get a better product. So that's becoming more and more common. And so I guess Creo 5 actually PTC introduced some generative technology. It was through a third party. Actually, it's a solution that Leap sells, one of their products. So PTC partnered with those guys. But in the interim period, they acquired some technology, a company called Frustum. So Creo 7, that Frustum engine was launched inside Creo. Okay, so there are two flavors of that. Initially, when it first launched, there was the Generative Topology Optimization extension. Try saying that 5 times really quick. So GTO. So this was basically to run on your desktop to feed it all of those things I just talked about. Okay, so give it some starting geometry, preserve geometry, manufacturing conditions. The beauty of this, it was completely embedded inside Creo, right? It's not, you're not farming out to some other system. It runs all inside the native environment. The other big thing is it automatically also automatically builds for you a manufacturable surface. So a lot of things where you take that externally, you end up with a faceted model that you then got to somehow bring back into your CAD tool and make that into smooth, nerve surfaces, manufacturable surfaces, whereas Creo does that itself. Okay, so this launched with Creo 7 at first release, and then a little bit down the track with a couple of maintenance builds, PTC launched the cloud-based Creo Generative Design extension, so GDX. So the idea of this is, when you're looking at a design problem like this, you might have lots and lots of options that you want to look at, right? So you might be looking at multiple materials, multiple manufacturing constraints. Maybe you're looking at, well, what if I, 3D print this versus, cast it or machine it, whatever else it might be. So they have different constraints to them. Different loading conditions as well, but you've got lots and lots of different options, and you want to look at those different combinations. Okay, so that's where the cloud comes in, because with cloud we've got lots of compute power. You can scale that up and feed it loads and loads of stuff rather than having to just send them one at a time, running them on our desktop. So the idea of this is we can set up all of those different conditions inside Creo, upload that to the solvers on the cloud, which will then go away and solve all the possible combinations. And then we've got a bunch of tools to look at, analyze that, compare and contrast, select which one we think is the best, and then feed that back into our Creo model to give us some full BREP geometry. Okay, so this is the cloud-based GDX. So some other parts, ANSYS powered simulation. So again, back in some early versions of Creo, it was Creo 6. Was when PTC started partnering with ANSYS to bring in some of the ANSYS technologies. So that was with Creo Simulation Live, first came in there, which is based on Discovery Live. So this was real-time simulation. With Creo 7, PTC also started to bring in some of the other ANSYS technology as well. Okay, so Creo Sim Live, as I mentioned, this was first introduced in early builds of Creo. So this was the Discovery Live. So this is basically a GPU-based solver. So that means it's hardware dependent. You need to have an NVIDIA graphics card in your computer that utilizes that to essentially solve almost instantaneously. Okay, so that was first introduced with structural, thermal, and modal simulations. With the release of Creo 7, fluid flow capabilities came in as well from Discovery. So that could be internal or external flow in a similar vein. You set up your model and let it grind away and start showing your results almost instantaneously. Okay. So the other part was Creo ANSYS simulation. So this is basically ANSYS Workbench engine. So that's the meshing solving tool. So again, that's being migrated into Creo. So with Creo 7 was the first release of that. You'll see in later slides how that's been evolving with releases. So this is basically ANSYS running embedded inside Creo and all of the capabilities that can bring. Next one at a high level topic was multi-body design. Okay, and this was really the big one. Okay, so Creo 7 introduced multi-body design as a set of design tools. Okay, so it lets you basically define different geometric volumes as individual bodies. You can assign different materials to them. As an example, you can use them for different scenarios. So really, PTC is quite famous for not having multi-body in Creo. It was introduced really to enable these different workflows for some of these new technologies. So for example, additive manufacturing, the ability to, define certain parts of the model to use lattices versus solids, or maybe different materials. In generative design, again, we have used different bodies for defining these different regions that we want to keep or exclude, or let the system muck around inside. Okay, so it's really basically giving you a different set of design tools to enable faster, easier, more flexible modeling. Okay, so speed, there are certain tasks that can be easier modeled as solids. So multi-body gives you a way to do that. Probably one of the most common ones would be around clarity here. So, multi-material parts, so the classic silicon injection molding, over molding, right? Where you've got one part with multiple materials inside that. So we can do that as multiple bodies. And just general flexibility. It could be around different pieces that might require different approaches. Simulation-driven design. So, in our example here, where really the important bit is the fluid domain. So we can model that up and create that as a body and use that to build our geometry. Okay. So multi-body was first introduced in Creo 7. This was a very big change, right? Probably the biggest change since the introduction of Creo, because it was really changing the way that the engine could behave. Now, if you don't use multi-body, that's fine. You can keep using Creo as you've always used it, as being all the way back to Pro Engineer days. It still behaves in that same way, but bodies are now an option there as well. Okay. And the last topic was really around additive and subtractive manufacturing. So again, back in Creo 3 was when PTC first introduced some of the additive tools inside Creo. So basically the ability to send your files directly to certain supported 3D printers. Creo 4 was, I guess, the big step there, where they introduced the lattice feature. So the ability to define these repeating structures inside your CAD model, rather than relying on taking that outside to some external software to then do that. Now that's fine if you're talking about prototype printing, but if you're getting into actual additive manufacturing, it's important to understand, well, if I make this as a lattice, what's that going to affect on the structural integrity of my model? Okay, so you find that lattice inside the CAD tool, perform your analysis, understand what's going on that was very important. Okay, and that's really why PTC introduced the lattice feature back in Creo 4. So in Creo 7, some more enhancements to that. So things around the ability to have user-defined lattices, so you can define your own part and use that as a lattice. We had a lot of queries from the universities who did a lot of research in this area, coming up with new optimal shapes. Some formula-driven lattices, so these kinds of things like the gyroid and other shapes that are built off a bunch of research coming out for self-supporting lattices. Stochastic lattices. These more sort of organic shaped things that can follow geometry, often used in medical implants where you want tissue or bone to sort of infuse with the implant. Okay, and some tools around optimization as well inside simulation. Okay, and then also some options around printing. Okay, so lots of printability checks and analyze for print direction around support structures. Particularly important when you get into metal printing, where you want to minimize support structures because you have to usually post-machine that off. Also, the ability to support added in support for 3MF files. So that's basically the new file format that's placed in the old STL format because it supports multi-material, multi-colors, and CLI files for metal printers for slicing. Okay. So that was some of what was there inside Creo 7. Okay. And then we move on to Creo 8. Okay, so Creo 8, which came out April of last year. Okay, so again, the sort of high-level themes there: usability and productivity, the general one; model-based definition and detailing; generative design and simulation; additive subtractive manufacturing. So a lot of common themes there. PTC has been spending a lot of time and effort in bringing these technologies, these emerging technologies, embedded inside Creo. And so these technologies are obviously rapidly evolving. And so with each release of Creo, we're seeing more and more of those capabilities coming in. Okay. So on the general usability productivity side, again, a whole ton of things. Some of the high level ones to discuss, the nice change to the dashboard layout. Okay. So the bit more text inside the dashboard. Probably gone a little bit too far down the icon path, but adding a bit more text in, particularly good for new users. So a little bit more explanation of what you're looking at there. The ability to control, the layout of the dashboard with, locking these panels into the graphics area, having them automatically appear whenever you start that feature. So if you're using them over and over again, they're always there, expanded out, ready for you to access a lot more quickly. The updating datum display, making them shaded and coordinate system with colors and things like that, so you can see them more easily. Other general things like dimension appearances, little things like putting the shaded background on the dimension so you can see it easily on the screen depending on the color scheme. Transparency control, so when you're working with multiple types of geometry, the ability to easily sort of fade out solid geometry to easily see tessellated geometry and the like. A big one was the model tree enhancements. Okay, so this was quite a big change, and it's been expanded in Creo 9, which I'll talk about in a little bit. But some options around some new quilts mode, so you can actually see quilts inside the model tree, kind of like you see with bodies. So this new ability to group things, the new design items folder, and the new design tree where you can show that. So it's a way of, again, sort of creating grouping of your features that's not dependent on feature order or history, but a logical way for you to, stitch things together to help you understand how your model's being built. Also included in that was this new snapshot for quilts or bodies. So this is a really nice tool. Basically, I can pick on a quilt or a body inside my design tree, and I could show a snapshot of that. So I could say, what did this quilt or surface look like when it was first created before it got merged and stitched together? So it will allow me to see the completed model as well as the surfaces used to build it, how it was when it first got created. Okay, I know it's a really common thing, particularly people doing surface design or working with a model that's been built that way. You'll roll through the model tree or use the model player to show how it's built. You can see those surfaces. The nice thing about this is you can see those surfaces, what they look like before they got consumed, while still looking at the finished product as well. Okay, so it's a nice way to visualize that information. So that was introduced back in Creo 8. Some hole feature enhancements. Okay. Plenty of things to do with holes. Sketch multi-hole, so the ability to define a sketch in one for your hole and then have it put holes on all the points inside that. Some updates to the standards, some new thread handling options in terms of when you're drilling through. The lightweight representation for all hole types, so that's the ability to represent that hole rather than as actual geometry, just to show a curve or a sketch that represents a circle. So if you've got thousands and thousands of holes in a model, that can definitely help speed up performance. But that was introduced, the ability to actually do that for all types of hole. Routed systems design, so some other things there like with the cabling, so new branch tape and stiff shrink stuff, features around your cables, so representing heat shrink and stuff. A little bit of stuff on the ECAD side for slots through IDX format when you're exchanging that with ECAD systems. The geodesic curve was introduced in Creo 8. So that's the ability to identify the shortest distance between 2 points across a surface. Okay, so it can be quite useful when you're working with things like maybe carbon fiber or composite manufacturing, things like that, or design, working at those shortest paths. Sheet metal mode, again, lots of nice little things there. The ability to create multiple flat walls on multiple edges in a single operation. So I can pick all of those edges to create a flat wall in one go. And also how we handle those walls and mitering and corners and things like that as well. Inseparable assemblies. Okay, so this was a nice new one. So the idea of this is you can do this, you can apply this for the Creo models. Probably where we see most customers using it is when you're dealing with imported data. So you might get a step file in for a motor, for example. Right, so you'll import that step file, and you'll get the motor and a whole structure of bits underneath it. There might be, 20, 30, could be 100, maybe even more sub-assemblies and parts inside that, right? But you don't want to deal with all of that stuff, okay? Because all you care about is the actual motor itself, right? So we could bring that model in. It'll create an assembly file for it, but then we can go and make all of the components, make it an inseparable assembly. So essentially it embeds all of those components inside the assembly. Okay, so you get this little icon that shows that. So the idea is that if you're working with directory data management from a file level, you'll just see .asm file, and that's it. Okay, it'll be a big assembly file because it contains the geometry of all the parts. Okay, but it's just one assembly file you have to work with. Now, all those parts are still separate items, right? You can still pick on them. They'll even support mechanisms and stuff like that. But you've only got one file you've got to deal with. And from the Windchill customer's perspective, then you've only got the one assembly file, which means you only get the one WT part as well for the assembly. So you have all these other bits and pieces you've got to worry about and manage. Okay. So this was introduced in Creo. It's a really nice tool there when you're dealing with sort of third-party data that you want to reference or use. Okay. Render Studio, okay. So Creo's been using Keyshot as the rendering engine in the embedded renderer for a while now. So with Creo 8, that engine was updated to use Keyshot 9.3, okay. So the big thing with Keyshot 9.3 engine was that it also could use your GPU. Okay, so up until that point, Keyshot had only been a CPU-based renderer and used the cores in your processor, and it was very scalable. It was great for that because you didn't need to have a special graphics card or anything like that. But you know, a lot of us have those graphics cards anyway for other stuff. So with Keyshot 9.3, it could also use the GPU as well if it detected a compatible card. So again, that had to be an NVIDIA card with the supported CUDA RTX cores inside that. So enabled a couple of extra things like the denoise feature, which was only GPU based. Okay. So that's some of the core stuff. On the MBD and detailing side of things, again, loads of enhancements inside this. So symbol modernization. Okay, so got a nice little overhaul there. So basically, in terms of placing and working with symbols, they're using the ribbon. So getting rid of the old dialog boxes and things like that. A new customizable symbol gallery you can use and pick from. A lot of stuff done on semantics, okay, across multiple areas. I'm going to talk about semantics a lot. For those of you who aren't familiar with that term, the idea is that you can see this note here that points to a surface, and the semantic references are basically all of the geometric references that particular annotation describes. Okay, so that becomes very important to, you want to put that note on. You don't want to just apply to that one little surface patch there. You want to pick all of the surfaces that is relevant to, okay? Because that can also be seen in downstream applications as well, okay? So there's been a lot of work done through symbols. You'll see some of the other slides later on around collecting all those semantic references. GDT for assemblies, so the geometric dimensioning and tolerancing. So basically the ability to now apply that when you're working in assembly mode as well, okay? So this is in the GDT Advisor tool that's available. When you're working with annotations, if you're doing a lot of this stuff in 3D, you have these different views set up to manage those. So basically some better tools for managing and working with those annotations inside that, okay? Surface annotations, okay, so a similar thing around adding some of those rule-based semantic references. So the ability to use all those things like seed and boundary surfaces, loop surface selection techniques to quickly select all of those surfaces you want for those references. Sketching tools, okay, so those of you who love doing drafting inside Creo, drawing lines in 2D, they did a bunch of enhancements there to add in more sketch-like tools inside there. So lots of snapping and moving and things like that. If you need to deal with any old DXF imported geometry or things like that. So much nicer to deal with that in Creo 8 for sure. On the simulation side of things, okay, so simulation is a big part, a lot of simulation-driven design. So the three areas there: generative design, Creo Sim Live, and Answer simulation. So sort of brought in earlier versions of Creo and continuing to enhance them. So on the generative design side of things, this sort of simulation-driven design where the computer works it out for you. So the local one, the GTO, the ability to run multiple design studies concurrently. So it was first introduced, you could only run them one at a time. So now you can run multiples if you've got enough resources there to work with that on your machine. Another ability is to automatically create the starting geometry, right? So I would define my geometry that I have to have, and then I can just say automatically generate a bounding shape around all of that, and then you can play inside that geometry, okay? So just with one click, you don't have to model anything yourself. A better reconstruction process. So, I was saying before how when you generate these things, you end up with a faceted model, but then Creo will automatically build a smooth surface feature for that using the freestyle tool, which was introduced all the way back in Creo 1. So essentially some tweaks to that in terms of how it handles that reconstruction process, the ability to bring in, like if you bring in parting lines to handle that a little bit better. Also new constraint around crease radius, so handling things around basically getting web geometry and things like that. Okay. For Creo Sim Live, okay, so Fluids was introduced in Creo 7. In 8, those Fluids was also updated to get you as also includes steady state results. So in Creo 7 is only transient. Some other flexibility around working with probes, sort of look at results in those different areas, basically making that a little bit easier to work with. On the Creo answer simulation side, as I said, first introduced in 7, and this is not a one click and it's all of answers is there inside Creo. Obviously, there's a lot of things to migrate across, so they've been continuing to expand that out. In Creo 8, adding in some more mesh controls, working with large deflection, some diagnostics and things like that as well. So basically increasing capabilities of that inside Creo. And then the other topic, a high-level topic, was again around additive and subtractive manufacturing. Okay, so on the additive side, one of the big things was simulation-driven lattices. Okay, so the whole point of the lattice feature in there is so that you can decide if I'm going to print this, if I'm actually going to make it in this way. I can run a simulation to see is the lattice going to be strong enough. But what we might have is a scenario where we might be wanting to hollow something out with a lattice to save weight because maybe it's going up into space or something like that, right? But what we're going to do is make sure that it's going to be okay. So we could generate a single lattice, but what we can now do is we can actually run a simulation on that first to work out what the loads are. Then when we apply the lattice to it, we can say, well, I want you to use the simulation results to drive that lattice. So what we can end up with is a non-uniform thickness of our lattice. As you can see in this cross section where it's thinner in areas of low stress and thicker in areas of high stress. Okay, so we can end up with a more optimal solution for that. So we don't end up with some uniform, really thick lattice that's going to account for the highest loading conditions in areas where we don't need it. Okay, so we've got the ability to drive that lattice based on the simulation. The stochastic lattices that were introduced back in Creo 7, so some updates to them around things like closer following of edges, some tools around when you actually generate that. If you actually generate that as solid geometry, there's a lot of bits of geometry that can go in there. So some improvements in that method of how it works, and working with some of the options inside that. Try and build enhancements again, more updates for that in terms of optimizing the building, finding overhang directions and stuff like that. As I said before, this is probably more important. We see this with customers doing metal printing. If you're doing plastic printing, usually you just want to build it, keep it flat to produce the vertical height to minimize your build time. Okay, because it's a lot easier, that you print in different materials, whatever, for your support material. So there's a lot of tools there for breaking that away. But with metal printing, because you're printing in metal, often you need to post machine that. So you really want to minimize the amount of machining. So you really want to optimize that angle to minimize support structure requirements. Okay. On the subtractive manufacturing side, okay, so PTC has been working with a third party around bringing some of their technology around machine simulation back in Creo 5, I think it was. Taj will correct me on this. There's also some high-speed 3-axis milling introduced back in Creo 5. With Creo 8, was also some high-speed 5-axis milling. Okay, so a whole bunch of high-speed machining processes around mold, particularly around mold machining. So lots of 5-axis stuff inside there. All right, so that's some of the stuff that was there inside Creo 8.